Welcome to VW 2.6. Today we'll be doing some advanced problems that deal with absolute values and inequalities. So before we get into it, there are a couple of notes we got to write down. Now we're going to make it a little more abstract. If you have the absolute value, let's call it a box, and it's less than a triangle. So I'll be using symbols to help us understand it. The key is less than. If it's less than, what happens is the box should be between the triangle and the negation of the triangle. So essentially we create an AND situation or an AND inequality, meaning our answer must be both less than triangle and greater than negative triangle. The other situation is when the box, or the absolute value of the box, is greater than the triangle. So the key here is going to be greater than. If it's greater than, that would mean that the box must be greater than the triangle, or, and the key word there is or, the box is less than the negation of the triangle. So notice how the greater than situation creates what's called an OR inequality or an OR situation. So to do these, notice how over here there are no numbers anymore. It's actually a variable. So that's why I use the box and the triangle to help us understand it. You look at the inequality and you want to note in your head, okay, the absolute value is less than that quantity. That means I'm in this AND situation. So I'm going to write 2x minus 3 must be less than, this is your triangle, and greater than the negation of the triangle. And notice how we have our compound inequality here. Now I'm going to separate them. We can't solve it like our normal number ones because it's a little more complicated. That's fine. Just create two separate problems like that and solve it like you normally would. So it's not that hard. We solve this. This would be x is greater than negative 1. I'll flip it around to make it nicer to look at. And this would be 5x is greater than 5. So x is, actually I'll fix that for you too. X is greater than 1. So notice how we have our two answers here. And the key is, again, the idea that it's AND. So we're looking for where these numbers, or where the numbers will satisfy both of these inequalities. So when I graph this, it'll make the answer more apparent. Here's negative 1 and 1. We want everything bigger than negative 1. And the keyword is, again, and everything bigger than 1. So for AND problems, we're looking for the overlap. And the overlap is going to be right here, because that's what it means to satisfy both of them. That's why the AND is there, which means our answer is simply 1 to infinity. So now let's try the other situation. So look at this one. Notice how this one says greater. So you don't note that. That's greater. And you don't have to write this out. I'm just writing it so it's quite clear for us. So greater is going to create this situation, this OR situation. So I'm going to write 3x minus 2, the box, must be greater than the 5x minus 1, or 3x minus 2 should be less than the negation. And now we're going to solve it. So to solve this quickly, that's 2x is less than negative 1. So x is less than negative 1/2. And again, the keyword here is OR. Let's solve this one. This would be 8x is less than 3. X is less than 3 over 8. So now when I graph this is not the same thing. Even though the problem looks very similar, look what happens when I graph these answers. Negative 1/2 is all the way there, and 3/8 is all the way here. For OR problems, we're looking for the answer that satisfies this stipulation or this stipulation, which means the answer is everything that is shaded. So again, for OR, you take everything that is shaded. For AND, you just want the overlap. So the answer here is going to be negative infinity to 3 over 8. And that's it. So now, let's go to our last advanced example. Notice how this example is a problem with multiple absolute values. So to do this is going to take a little bit, it's going to be a little bit more tricky. So I'm going to show you what absolute value means to help you approach this. So over here, let's write down a few notes. I want you to understand absolute value as a computer program. So think of it as a program. Absolute value of the box. There are two things that happen. If the box is greater than 0, meaning like let's say it's absolute value of 10, positive 10, nothing happens. So what happens is this program or this computer will simply return box. Right, so if you imagine, put a 5 here, 5 is greater than 0, the answer is 5. So that's all that's saying. But if the box is less than 0, that's where it gets a little more tricky. If it's less than 0, what happens is this program will negate the box. Meaning, let's say we plug in -1. So -1 is less than 0, so we're going to take this bottom path, which means it'll negate it, making it +1. So that's how you'd explain absolute value if it were like a computer program. If it's positive, you do nothing. If it's negative, you just negate it. So let me get rid of those now. And again, just to show you the example to make it a little more clear, we have 5. If it's positive, do nothing. If it's negative, we simply negate it, and that's how we get to 5. So to approach this question, what we're going to do is this. Create a number line using centers. So here's our line. Notice how the centers are -2 and 2. So think back to the centering method, same idea. So -2 is here, 2 is here. And from there, I just want you to drop these dotted vertical lines down. What we're doing is we're separating all the real numbers into 3 regions. In this region, we're saying x is less than -2. In this region, we're saying x is between 2 and -2. And in this region, we're saying x is greater than 2. So if I'm working in this region, the assumption is x is bigger than 2. So these are all like assumptions. So assume, assume, assume. And that's a really key assumption, because if we're working in this region, we're assuming x is bigger than 2. That means these absolute values don't do anything. So if you're wondering what that means, let me show you here. Let's say we pick 3. If I plug in 3 here, I get absolute value of 5 minus absolute value of 1. Notice how both of these are positive, which means absolute value doesn't do anything. And that's true for everything in this region. So we ignore them. We're going to write x plus 2 minus the quantity of x minus 2 is greater than x. Because in this region, if we assume x is greater than 2, which is where we're working, the absolute values have no meaning. And now we can solve it. Notice how these x's just cancel. We get 2 plus 2 is less than or greater than x. So x must be less than 4. So look, we have one answer here. Now we go to this region. We're assuming x is between -2 and 2. So let's say you pick a number. Let's say you pick 0. You plug in 0, you get absolute value of 2 minus absolute value of -2. Notice how this first one, it doesn't do anything, right? It's still positive. So that's why for this one, you simply write x plus 2, because the absolute value does nothing if we're greater than the center. So that's why this one, notice how we did nothing. But look at this one. This one came out negative, which means we have to negate it to fix it. So we're going to write plus, or you can think of it as negative x minus 2. But it's probably easier just to write a plus. Just think negate this thing right here. So plus x minus 2. These cancel. We get 2x is greater than x. X must be greater than 0. Okay, there's our answer. On the final region, hopefully you can guess what's going to happen. Let's say you pick negative 10. So that's negative 8, negative 12. Notice how both of these are negative, which means the absolute value is going to negate them. So we're going to write negation x plus 2, and then negation of x minus 2, so plus x minus 2, that's greater than x. And now we solve it. Negative x minus 2 plus x minus 2 is greater than x. Notice how these x's cross out. Negative 4 is greater than x, so x is less than negative 4. So now we put the answers down. Negative 4, x is less than there, so notice how this fits perfectly. So this means if x is less than negative 4, the equation holds true, or the inequality holds true. Right here, x is greater than 0, so we'll put a 0 here. And I stop here because we don't know what happens here yet. And then 4, x is less than 4. I'm going to shade here. The only thing to be careful of is this point 2. We don't really know what's going on. So to quickly check, we're just going to plug it in. So plug in 2, we get absolute value of 4 minus 0 is greater than 2. This checks out. So this 2 is going to be closed. We include that. So with all that work, so now we have our answer. Our answer is negative infinity to negative 4 union 0 to 4. And recall that union just means or. Okay, so good luck on the homework and try your best. This is hard. I'll talk about your questions in class.